I'm Na Meng, an assistant professor from Virginia Tech. Today, I'd like to introduce our recent investigation on NPM packages. This is a collaborative project with my students Prannoy, Saksham, Zhiyuan, and my colleague Daphne. Node.js has been popularly used for web application development, partially because of its large software ecosystem known as NPM packages. When using open source NPM packages, most developers download pre-built packages on npmjs.com or the npm.js registry instead of building those packages from available source. And then they implicitly trust the downloaded packages when building projects on top of those packages. However, it is unknown whether the bluntly trusted NPM packages are reproducible. In other words, it's still unknown whether there's always a verifiable path from source code to any published NPM package. In our research, we were curious about two research questions. First, are the pre-built packages on npmjs.com always reproducible? Second, if reproducibility is not achieved, what are the potential reasons? Therefore, in this project, we conducted an empirical study to examine the reproducibility of NPM packages and to understand why some packages are not reproducible. To do the investigation, we first obtained the URLs of 226 most popularly used packages from the NPM rank list provided by GitHub. Each URL corresponds to a web page on npmjs.com. From each package, this step obtains the related GitHub repository link and all published versions of the package, such as PN1, PN2, all the way down to PNM. From the GitHub repository, on the other hand, we also retrieved the code commits corresponding to those published versions, including C1, C2, all the way down to CM. Then, we adopted the standard NPM build procedure to generate package versions from source code commits. Theoretically, if all published versions are reproducible, the versions we generated with this standard build process should have bit by bit equivalence with the published ones. Therefore, in the third step, we used an off-the-shelf textual diff tool, diffscope, to compare each rebuilt version with a related published version. If there is any revealed difference, in the final step, we conducted a manual inspection to understand and reason about the observed differences. Based on our investigation, surprisingly, we found about 38% of the studied versions to be non-reproducible. With our manual analysis, we classify the observed differences between versions into 7 categories. For instance, C2 means that one version has a longer expression used as an if condition, while the other version under comparison uses a shorter but semantically equivalent expression. C4 means that the two versions under comparison refer to the same variable with distinct names. Overall, the observed differences of the first 6 categories are the syntactic differences that implement equivalent semantics. However, C7 includes semantic differences. We also further investigated the build process to understand why those differences occurred. So far, we identified some reasons to explain the observed syntactic differences, such as the version relaxation of some used libraries and the distinct optimization strategies adopted by the different versions of uglifiers and transspellers. In the future, We will explore why semantic differences exist between versions and further investigate whether those differences indicate any bugs in the uglifiers or transvalors, or indicate security vulnerabilities in NPM packages. This concludes my talk. Thank you for your attention.